Hi, this is Ian Magaha, and I'm doing problem 4 for coding set 2. It is, I mean, in essence, it is exactly like problem 3, which is up here, where we created a program that calculates minimum fixed monthly payments needed in order to pay off a credit card balance within 12 months. And the only difference is that we are doing so recursively. So we are still using bisection search, we are still using a balance of 5,000 and an annual interest rate of 18%. So to start off, we are obviously setting our balance to 5,000. We have an annual interest rate of 18%. We have the low is just the absolute lowest payment that we can start off with is assuming that we have zero interest rate and we are paying over the course of 12 months. And then the highest is we are literally waiting to the last month to pay the entire balance off in full with all of the annual interest that has accumulated over the 12 months. And then our minimum payment is just going to be, in between low and high. So it's the average between low and high. So in order to use recursion, we're going to need a function. And functions are just useful for reusability of code. So after watching the professor's video, which is very helpful, reusing code is really useful, or using functions for code is really useful when you don't want to have like a million fragments of code in your program. So just in your code. So imagine if I had to look at problem 3 and I had to, just copy and paste this 11 times. I have 11 while statements in my code. There's no reason to do that. Well, instead of having to do that, I can just use the one function that is defined. Also, if I need to, let's say, change the months, like we're doing 13 months instead of 12. Instead of having to go in each individual while loop and change the range to 13, I can just do it once for the function. So functions are really useful in reusability. And then recursion, it's just looping without a loop. So we're looping by calling a function within the function. So how we do that here is, well, we have our function, it's called find payment. We are inputting a balance, an annual rate, the low, and the high. So minimum payment initially is going to be, minimum payment always is going to be your low plus your high divided by 2. The average between those numbers, and as we get closer to the number, we're going to average on the correct number, squeezing in on the correct number. And then obviously new balance right here is going to be equal to the balance that is input. So we are going to have a loop inside this function. So for month and range of 12, so we're going 0 to 12, which is going to be 12 months. We are going to take our new balance and we're going to subtract by the minimum payment, and that's going to be our new balance after paying our minimum payment. Then we're going to add new balance times the annual interest rate divided by 12. That's just going to be adding our interest. And if this new balance is between 0 and 0.01, then we're going to return the minimum payment, and we're also rounding it because we're dealing with dollar currency right now, so there's only going to be 2 decimal places. So we're going to round it, and we're going to round it to 2 decimal places, and that's going to be our lowest minimum payment that you need to pay each month in order to pay it off in 12 months. Now, in the case that the new balance is less than 0, which means that the minimum payment is too high because it ultimately, overpaid on the balance, then we're going to run the function again, and instead of taking a high variable, or instead of taking high, we're taking minimum payment. We are setting minimum payment as our highest minimum payment that's allowed, because that minimum payment was too high. It brought us below 0, meaning that we overpaid on that balance. Now, in any other case, which is really, we only have one other case, which is that new balance was greater than 0. In that case where new balance is greater than 0, obviously our minimum payment is too low. So we are going to say we're going to input minimum payment instead of low, where low is supposed to be, because our minimum payment was too low. It did not pay off the full balance. So we are going to return and do the function again. And so we have a recursive loop where we're returning our function until we find that until we find a minimum payment that is between 0 and less than or equal to 0.01. So when we do that, let's go ahead and run the code. We found that the lowest payment is $451.63, which is our expected value. So this overall is very, very similar to our 2.3 problem. We are just, instead of using that while loop where we just endlessly loop until we break out, if we find that the balance is between 0 and 0.01, we are now, instead of using that while loop, we are just recursively looping by calling a function within itself. And that is how we solved problem 4. I appreciate you watching, and I will have a new video pretty soon. You have a good one.